Good afternoon, everybody. I'm Rob Shepard. I'm the GIS librarian at the University of Chicago, and together with Teresa Quill from Indiana University, I have the privilege of serving on our speaker series committee to decide on who would be our keynote for today's presentation. And it wasn't much of a search. Right away, we settled on Frank Donnelly from Brown University. Frank is a geospatial information professional whose work integrates geography with library and information science. He has several decades of experience with GIS and geospatial technology. He was an early adopter of open source GIS in higher education. In crafting library data services, his vision has been to go beyond just helping people discover and use data sets to actively creating publicly accessible data products and tutorials that enhance research and teaching. An expert in government data sets, he is the author of Exploring the U.S. Census, Your Guide to America's Data, and he's an active volunteer with the Data Rescue Project. He's currently head of GIS and data services at the Brown University Library, and he manages the library's geospatial data center, GeoData at SciLab. He previously served as a geospatial data librarian at Brooke College, CUNY. He holds an MA in geography from the University of Toronto and an MLIS from the University of Washington. You can read more about his work on his website at these coordinates, which is at coordinates.info. Without further ado, I'm going to turn it over to Frank to give our keynote presentation. Thanks.
All right. Thanks so much, Rob. Let me just get the slides fired up here. Okay. Is everybody able to see my screen? Can I get a thumbs up? All right. Thank you. Thanks, everyone. It's a pleasure to be able to join you today. I hope you're enjoying the conference so far. Thanks so much to the Big Ten Conference organizers for inviting me. My name is Frank. And this afternoon, I'd like to share this project and really the story with you about rescuing HIFLD Open, an effort to save America's data. HIFLD Open was a federal GIS data repository that thousands of us used and relied on, but it was discontinued and deleted from the internet last summer. So there are several things that I hope that you can learn from today's presentation. The obvious one being, where did all this data go, Frank? Where can I find it now? Yes, I'll let you know where you can find it now. But more importantly, I wanted to take the opportunity to discuss the importance of the U.S. federal government data and statistical system to our work as GIS professionals and as students, to raise awareness around many of the data preservation efforts that have been going on, and particularly the efforts of the Data Rescue Project. And also, I'd like to share some insights on project management that I learned from coordinating this large project. So the heart of the presentation today will be the HIFLD Open Rescue Initiative. But before I can really talk about that, I need to give you some background about the Data Rescue Project, of which the Rescue Initiative for HIFLD Open was a part of that. Before we can talk about that, we should really talk about the federal statistical system and its role and importance as a vital piece of national infrastructure and as an important component of all the GIS work that we do. So that's the plan for the keynote, and we will begin at the beginning with the federal statistical system. What is it? Well, it's a vast ecosystem of bureaus, units, and offices within the government whose role it is to produce, analyze, and distribute statistical data, which includes GIS and geospatial data. And while the system is highly disaggregated, there is a lot of collaboration and coordination across that system, where folks in the different agencies are sharing information and resources to one another, and they're also helping to ensure that there are standards and best practices that they're all following. This is not just some sprawling bureaucracy that exists for its own sake, but there's a reason why all of those different bureaus and agencies exist and why we have this system. And the basis is grounded in law, and we can go right back to the Constitution and see where the origin of the system was. And in talking about this, I'm really drawing from the work of Margot Anderson, who is a history professor who has done a lot of research about the history of the federal statistical system and about the census in particular. She wrote a book called The Social History of the U.S. Census, which is really kind of the touchstone work for census history. And in this article that she wrote, she talks about these three sections of the Constitution which are really kind of the origin of the federal statistical system. Article 1, Section 2 might be the one that some folks are familiar with. This is the article that mandated the census, so an actual 100% count of the population so that we could use those numbers for reapportioning and redistricting Congress. So that article and section is really the basis of all the demographic surveying that we do. Maybe not as well known, Article 1, Section 9, that specifies that the government has to keep a statement of accounts, all of the budget and the transactions and what the government is spending money on. And not just the transactions themselves, but rationale behind the transactions. And, where do you get that rationale from? Well, part of the way that you get that is from collecting data. And then Article 2, Section 3, the State of the Union. This is not just that, speech that we have to listen to every year. That's kind of a contemporary phenomena. But what this really refers to is that, in theory, the legislative branch is supposed to be passing the law and the executive branch executes it. And the executive has to report back on the State of the Union to Congress periodically to show what's being enforced. And one of the things that you need in order to create those reports is a robust federal statistical system for creating data. So this is really the basis, the original basis in the Constitution. And then, of course, over the last 200 plus years, there are a lot of many statutes in federal law that mandate that we collect certain statistics. So we've been collecting very detailed data on unemployment since the Great Depression because it's something of vital national interest. And we have an unemployment kind of welfare system that we need this data for. There's an initiative to make sure that everybody has broadband access. Well, we have to collect data on who has broadband access in order to enact that initiative. If you're interested in knowing more about what those federal laws are, the Congressional Research Service has been publishing a lot of reports in the past 2 years about the system. And this is one that I would recommend. It's recent, which will kind of delve into that a little bit more deeply. So that's the basis. But then these final two bullets here, these are kind of things that are maybe a bit more quirky, but they have ensured that federal data is really a robust part of our democracy. The first thing here is actually our copyright laws. So everything that the federal government produces is free and in the public domain. If you look at other countries in the world, that's actually a little bit unusual. Most countries will copyright their data, or they won't have anything specific that specifies that it's accessible. But here, that really has lowered the barrier of entry for people to get access to federal data, so everybody is using it. And then perhaps even more quirky than that is this series of paperwork reduction acts, which was actually designed to prevent the government from constantly asking people too many questions, so that it sets up some restrictions on, if the government wants to add additional surveys, they have to go through a process of getting approval for that. But with this act, specifically the one from the 90s, what it also did was it basically set up the relationship between the government and its responsibility for reporting data to the public. And it also stipulated and encouraged the government to use information technology to disseminate data. So instead of pushing a lot of paper back and forth, that data should go up on the internet so that it's easily accessible. And of course, 1995, this was the flowering and the beginning of the internet. So because of that, because of the way that our Constitution is written, and because of these federal laws and these mandates, we have wide access to government data, and we use it for all kinds of things. It provides essential information about how our nation functions. The data is used for allocating billions of dollars in federal funding to states, local governments, and individuals. It's used for education and teaching, for planning, research, policy and decision makings, and basically all spheres of life that you can think of. It is integrated into any number of products and services, and it's used for benchmarking. This is something that I think people don't think about as much, but just to give you an example, we're working on a project right now where we're evaluating commercial data providers who are publishing business directories. So I want to know what every business is in this particular area of the United States. How do we gauge how accurate or complete those products are? Well, we can use, summary data from the government, like from the Census Bureau's county business patterns, for example, to measure how complete the counts are in the products. And then beyond publishing the data, the government also publishes standards for how we categorize and measure that data. So all of those business establishments, how do we classify them into industries? We have the North American Industrial Classification System that the government maintains. How do we define unemployment so that we make sure that we're collecting the same numbers? So these are all like general applications of how we use federal data. And then for us specifically as GIS, researchers, students, and practitioners, the US government provided the data sets that really helped to propel desktop GIS technology. So think about, when you fire up ArcGIS Pro or you launch QGIS, you have a blank screen there, right? And there's no data. Turn back the clock 30 to 40 years ago when the internet was not, was brand new or not even there yet. It was harder to get data, but the government started publishing and providing, the Census Tiger line files in 1990. The USGS was providing the digital raster graphics of the USGS topo maps. And maybe some older folks here may remember this digital chart of the world. This was one of the earliest attempts to provide detailed boundaries for all of the countries in the world. And this was created as a project that NEMA was doing. So without any of this data, it would have been very hard for desktop GIS technology to get going back in the day. And of course, the government continues to create and publish GIS and attribute data that we rely on. Agencies like NOAA, the Census Bureau, the USGS, and many, many more. So in essence, then, the federal data infrastructure has really become a vital component of our national infrastructure. So if you think of things like the interstate highway system, Amtrak, the Postal Service, public TV and public radio, these public goods provide a floor on which the foundation of our economy and our society can rest. And the reason that a lot of this particular stuff is public is it's not something that the private sector can profitably or equitably provide. And it's federal because in order for it to function, we can't have, 50 different data collectors cobbling things together, but we have kind of a unified national system for collecting that data. But imagine if you would, like tomorrow, if the government went out and started demolishing random sections of the interstate highway network, and suddenly 5 or 10% of the roads were just destroyed over the period of a few weeks. That would have a serious and very immediate impact on people and local communities just trying to navigate around their city and town. It would also have a ripple effect across the entire network as people and goods are trying to move across the country. It would be something that would be very noticeable. But this same damage is actually happening right now to our federal statistical system. But unfortunately, this damage is not as noticeable to many people in the general public. So, for example, you can imagine NOAA is constantly creating a lot of climate data that it's generating from models. Most people are never going to look at that data, but that data is basically used to create other models and input to, giving us reliable weather forecasts that we all rely on, which is something that's not as noticeable, but does have a ripple impact and is going to be very disruptive. Or examples of, with the shutdown, the Bureau of Labor Statistics was not able to release its surveys. And then the market is kind of in the dark in terms of trying to evaluate, what's going on with the economy in terms of unemployment. And then even within our own specific work doing GIS research, there's an example like here in Providence a couple of years ago, there's actually a bridge that's part of the interstate highway network here that was taken out of commission because it was like in danger of collapsing. So they closed the bridge down very suddenly, and it caused like a nightmare scenario in the community in terms of traffic. And I've had several students who are interested in like studying what this impact on the community was. But the problem that we're finding is that when we go to the National Highway Statistics, the data basically stops in 2024, and we don't have data released for 2025 that we can use to evaluate what's going on. That's a problem for us just doing, student research projects for class, but imagine the impact that that has on local governments and policymakers who are really trying to deal with these problems. So since the beginning of 2025, the government has been either removing or modifying data sets. It's kind of hard to keep track of exactly what is disappearing. This website from America's Essential Data, who was put together by one of the people behind it is one of the former chief data scientists of the United States. So you can go and take a look at this page and you can get a sense for what is being removed and what is being discontinued. In some cases, this is the government making some deliberate decisions about removing certain data sets that maybe the administration is not particularly fond of. But the other aspect of this is that there are a number of reductions in force. A lot of federal employees have been laid off, and the people that maintain these data sets are no longer there to maintain them. So this is a serious, serious problem. And occasionally, some of these losses have been more noticed and are something that impacts the public a lot more directly. This is a good example, the CIA World Factbook. This was something that's been published or was published since the early 1960s, and it was a very fundamental reference source for getting data and information about all of the countries in the world. So this was something that was not only used by analysts and diplomats, but was used by elementary school children in social studies class to learn about different countries. So things like this, do get widespread attention in the mass media and in social media. And there were many initiatives that were launched to save this data or put up a new website based on the data that had been archived. But for a lot of the stuff that we rely on, it's just not as visible and it's outside of the public eye. So who is going to preserve that information? Well, enter the Data Rescue Project. So the Data Rescue Project was one of many projects that was launched in the beginning of 2025 to respond to the removal of federal data from the internet. And I should give you a little bit of a disclaimer here first. In terms of my role with the Data Rescue Project, I'm an enthusiastic volunteer, and I coordinated the one initiative around HIFLD Open. But I'm not like the organizer or leader. I'm not on the steering committee. I'm not a spokesperson. So in describing this to you, I'm basically giving you my interpretation and my point of view as a volunteer. But this quote here is the official description from the Data Rescue Project. They are a coordinated effort of these three data organizations, and their goal is to serve as a clearinghouse for data rescue efforts and data access points for public U.S. government data that is currently at risk. This project is made up of volunteers who are librarians, archivists, data specialists, data aficionados and hoarders, students, and generally anyone who is concerned about the loss of data. And in my interpretation, there are basically two different roles that the Data Rescue Project fulfills. The first role is this clearinghouse role. The Data Rescue Project is keeping track of all of the different, or as many of the different data rescue initiatives as they can, and they create connections between the people that work in those different projects. They share resources, they share advice back and forth, and they kind of raise awareness around data rescue. And the second role that they play is that they have their own internal mechanisms for preserving and archiving data. So an example of the first mission, like the clearinghouse mission, they've created this data rescue portal, which is a catalog of rescued data sets from many different rescue efforts. So if you're curious about was a particular data set that you're interested in, was it preserved, you can go in here and do a search, and then you can find out exactly which project preserved it, and then you can get a link back to that original data set. And then for that second role, this kind of internal process, this is kind of a description of what that workflow is. I'm calling this like the standard workflow, but that's just my interpretation. This kind of standard workflow is really kind of what predominated over the course of 2025. So the way that it will work is some tips would come in from different sources that particular data sets were at risk from being deleted. There would be a discussion on Mattermost. Mattermost is a Slack-like communication channel that the DRP set up for the whole project. The organizers would then go in and create tabs in a Google spreadsheet dedicated to individual agencies, and they would populate that spreadsheet with a list of data sets and URLs. And then other volunteers would hop in, sign up for a data set that they wanted to rescue, and then they would use various means of downloading it from the sources. They could be pointing and clicking and manually downloading things, or they could be writing like a Python script to like screen scrape the data from the website. Once they got the data, then they would upload it into Data Lumos, which is a federal data repository that is sponsored by ICPSR. and we would upload it into Data Lumos, and you would create a basic metadata record for it. The spreadsheet was used for tracking the progress, Mattermost for coordinating and getting advice, and then the organizers would basically, make sure that things were on track. Ultimately, they would ingest records into that data catalog, and then they would hold regular office hours and like hackathons to kind of promote awareness and get people volunteering. So that was the workflow that, for much of 2025. But then there were also these kind of bespoke workflows where within the project, or sometimes via different partnerships, small teams would emerge to work on a specific data set that people were interested in. And in some cases, this would use some of the infrastructure from the regular workflow, or in other cases, it would be completely bespoke. And as we're moving now into 2026, and the kind of firefighting mode of we have to save stuff is kind of tapering off a bit, there are more and more, I think, of these kind of bespoke sort of workflows that are popping up over specific data sets. This is an example of the rescue inventory spreadsheet. So you can see at the bottom, there are a number of tabs, devoted to different agencies. There's a list of data sets with URLs, and then folks would come in here and put their initials in here and claim a data set. Then they would go and take care of it, and then subsequently come back in here and update the progress that it's been rescued or saved. And this is Data Lumos. This is the repository that was set up by ICPSR for the purpose of hosting these preserved federal government data sets. And it's a basic repository that allows you to do keyword searching and also filtering. You pull up a specific data set, you can click on it, you get a catalog metadata record, and then you have an option to download it in several different formats. My work with the project started, very early in 2025. I was basically, in the early days, I was just working on my own, saving some data sets that I knew that were important to me and to other faculty at Brown, sitting at my, kitchen table in my undershirt late at night, writing code, saving stuff, until a colleague pointed out to me that the data rescue project was a thing. And then I joined up and then started contributing the stuff that I had saved, and also started chipping away at the standard workflow with data sets that were in the rescue inventory. A work I was doing, I tried to automate as much as I was doing. I was using Python with the requests and beautiful soup module to basically screen scrape web pages and download any data files from those web pages. And then later on in the spring, within the library at Brown, there was a loose team of my colleagues that got together, and we started participating in this as a group. Once in a while, the DRP organizers would tap me on the shoulder and say, "Hey, Frank, can you help with a specific project?" And we would hop in and do that. And then in other cases, faculty here at Brown would come to us and express concern about data that was disappearing. And then we would go in and address their specific concerns and add that to the project. So for example, this climate change and human health literature portal, there was a public health professor that was using this in his course. This is an example of a data set that was deleted and went away. His research assistant had managed to grab the JSON file behind it, and we went in and basically created a flat CSV file for it, wrote some documentation, and got it into the Data Lumos repository. So that was the work that was taking us into the spring. And then into the summer, things were kind of quieting down a little bit, at least for me. I was hoping that, I finally got an opportunity to go and take a sabbatical, which is like, something that's very rare, like a sighting of Halley's Comet. That's how often that happens. But there were clouds on the horizon. And this brings us to HIFLD Open. What is HIFLD Open? This is the Homeland Infrastructure Foundation level data. Quote at the top is a description from their website, now gone. This is public domain data for community preparedness, resiliency, research, and more. It was a central clearinghouse that gathered national infrastructure and environmental GIS data sets all in one place. It was created by the Department of Homeland Security's Geospatial Management Office. At its peak, it had over 400 GIS data sets from dozens of different US federal government agencies. And based on my research, it looked like there was an early version of this back in 2016. But the most recent iteration of it was an ArcGIS hub site. And what was in there, I have some examples on the left, basically infrastructure data and then environmental layers that could impact infrastructure. And the idea was that, okay, I could go to HIFLD Open And if I wanted to study the location of hospitals relative to flood zones, and I wanted to get information about what cities and towns they were in, instead of having to go to 3 different places to get that data, I could just go to one place, to HIFLD Open, download what I need, and then I was ready to go with my project. Now, I frequently visit GIS courses at Brown, and I give presentations on where you can find data and data management practices. And this was always one of the primary examples that I've cited. But of course, HIFLD Open was not really designed specifically for us, but it was designed really by folks within the federal government so that they could easily share data among agencies, and they could also share it with state and local partners for emergency management planning and policy. But obviously, it was widely useful to everybody else as well, until it was removed. So on June 24th, the DHS announced that the whole portal would be discontinued by the end of September. It's worth noting that this portal, I had spoken to some people that were involved in its creation. It actually took years of collaboration to put this together. And then just in the course of the summer, a decision was made and it was going to go and be taken down. And then in late July, the closing date was actually moved forward from the end of September to the end of August. I learned about this in early July, and that prompted me to quickly pick up the phone and call the operator and say, give me the data rescue project. And no, not really. What we did was within the Mattermost channel, there was specifically a channel for posting things that were urgent. So I hopped into that urgent channel and I said, hey, everybody, did you know that this was a thing that's happening? And then a big discussion ensued about saving the layers. The discussion hinged on whether or not we should do this because HIFLD Open wasn't the creator of this data, it was an aggregator. And most of the data sets from the 30 different agencies were still out there somewhere. But ultimately, we decided that there was real value in preserving this data as a final snapshot of this collection. And of course, many people that use HIFLD Open didn't know or don't know that it's available in 30 different places. This was the place that they went. So we decided it was something that, it was worth preserving this as a final snapshot. So everybody agreed, Frank, this is a thing that you should do, and let us know what we can do to support you. And I said, oh, okay, all right. So I went out and I started scoping out a workflow using the standard process that I had mentioned earlier. How can I write documentation and convey to people that go to this portal, download these files? But then the shutdown timeline was advanced from September to August. We're already at the end of July. It was looking like my plan was not going to be feasible. But hey, because I went into Mattermost and we created this discussion, one volunteer contacted me and said, hey, Frank, I know that you were interested in doing this and putting this plan together. I wrote a Python script that reaches out to the API and is able to pull down all of the data from the portal. Would you be interested in using that? And I said, yeah, I'm kind of counting on that. So let's do that. Interestingly, I don't know the names of a lot of the people that are involved in the project. When we're in Mattermost, people use handles, so we can remain, somewhat anonymous. So I only know my partner by their handle. Their name is Triple Shrimp. And thanks to Triple Shrimp, the two of us put our heads together. We created phase 1, where they were going to download all the data from the API before it disappeared. And then once we had all the data, we could move into a phase 2, where we could basically marshal some volunteers from the data rescue project to upload it into Data Lumos. Now, on this exciting slide here, this should warm the hearts of all of you metadata nerds out there, because it was really metadata that made this rescue process possible. So this JSON file was embedded deep in the guts of the ArcGIS Hub site for HIFLD Open, basically one record for every single data set in the repository. So Triple Shrimp was able to use Python to loop through this JSON file and grabbed, the name of the data set and created a folder based on the data set's name, grabbed all of this metadata, which we were going to need to use for recreating the catalog records in Data Lumos. And then embedded in here are links to that data set in many different file formats. And we decided, okay, we're going to grab at least 4 different formats just to make sure we have that data in different versions. GeoJSON is really good for preservation since it's plain text. We're going to get shape files too. They're like a bad pennies that always turn up, but people are still using them. So we'll grab that. We'll grab the geo packages. That's like the nicer or better version of shapefile that folks are using. And we'll grab Esri file geodatabases because some of these data sets are so large that that's really the only format that's really like feasible for working with particularly big data sets. And then also there's XML metadata in an FGD standard for most of these data sets. We're going to grab that too. So using Python, loop through this file and start downloading all of this stuff. While Triple Shrimp was downloading all this stuff, they were passing an updated file to me of downloads that failed for one reason or another. And then my job was to go in and fill the gaps and figure out, the data that wasn't able to download, what happened and where can I get it. In most cases, data sets that were really large, that had tens or hundreds of thousands of polygons or line segments, were just not retrieved through the API. We'd have issues with it timing out or failing. So what I would do then is that if I couldn't get it through the portal, I would go to the source. And many of these sources, like this one, the U.S. Geological Survey, this is the watershed boundary data set. All of these layers are just in a single geodatabase. So I could download that geodatabase, go through each of the layers in the database, export and save them, and then basically make sure I'm following the same conventions for naming and organizing the Triple Shrimp was, so that I filled in the gaps for the stuff that wasn't there. And then we had to figure out a way of, well, how do we share our stuff? This was not a job for Google Drive or Dropbox because our dinky accounts were not going to be able to handle the data in terms of how big it was. But luckily, I had access to this mechanism called Globus, which is created at the University of Chicago. And it is a mechanism for transferring big data files between two endpoints. The idea is that you establish with the Globus software an endpoint on your laptop, a server, cloud storage, a piece of scientific equipment. You have an endpoint established in one location, you establish an endpoint somewhere else, and you use this Globus software. It looks like an old school kind of FTP site, but it's actually a lot more sophisticated than that. It doesn't go through your browser or through the traditional internet, but it uses back channels to efficiently transfer big data sets from one endpoint to another, and also has all these things built into it to ensure that integrity is maintained when you're doing the transferring. So that was a lifesaver in terms of finding a place to store everything. The endpoint at Brown was just a traditional server. And then there was a lot of, once we got all of the data, each individual data layer, all 400 of them, were placed in a folder that was named for that data set. We had to identify the missing data sources, fill in the gaps. In some cases, there were a lot of artifacts that were not data sets, that were just components of the hub site that I had to go through and basically identify and remove. Triple Shrimp was not a GIS person, so they asked me for some assurance that, in downloading all this stuff, is it actually complete? Did any of it fail? So instead of trying to add 400 layers one by one into QGIS, which is not going to be feasible, I wrote a script with GeoPandas, and I quickly created a plot of the GeoJSON files of every data set. We could quickly just skim through all of those plots and look at this one on the right and say, yes, that looks like all of the Amtrak stations in the United States, and have a little bit of confidence that, the files are good. And then we had to create a new inventory sheet for tracking everything. It mirrored the one that the data rescue folks already used, but it also had to include additional information about the folder location in Globus, and then all of that metadata that we needed to keep so that people could fill out the catalog record. Because again, in a traditional rescue, the rescuers are on the web page and downloading the files, and they can look at the web page and get information about what the data is about. But in this case, the portal is gone. So there's nothing except this metadata. So we had to make sure that we kept it in the inventory sheet and available for people to use. I'm a stickler for documentation. I wrote 2 different sets. One was for transferring data from the Globus endpoint, because that's not something that anyone in the project would have any familiarity with, because it wasn't being used for other things. And then another set of documentation for uploading that data and creating the metadata in DataLumos. Many of the existing volunteers were already familiar with this, but this was our opportunity to really standardize the metadata, because these files were not just going to be one-off files, but they're part of a collection or a set. And we want to ensure that when people search for the data, that they can actually get everything in that particular set. So we identified the specific metadata elements that we wanted everybody to use, and then also what should go in those elements. So the project title, for example, should always start with HIFLD open, and then the very specific name of the data set that is used. The subject terms, HIFLD open and GIS should always be a subject term. So we outlined all of this in this document so that, again, when people are uploading the data, creating those records, they have a template that they can look at. So all of the preliminary work that the Triple Shrimp and I did for setting everything up, that took place from late July to mid-September. And then once that was done, we were ready to move to phase 2 and get some volunteers to begin doing the uploading process. And it was important to get all of the details for the process kind of set up in advance to really make it easier for the volunteers so that the workflow was as consistent and smooth as possible. So the new workflow is going to be, hopefully everybody would read the documentation. The documents were linked to from the inventory spreadsheet that people were filling out, and also from a dedicated channel in Mattermost that we created just for the HIFLD project. People would sign up for a data set. They'd have to create an account in Globus and transfer that data to their laptop or desktop. Optional step, if they wanted to, they could open it up in QGIS just to take a look at it if it made them feel better about describing it. But optional. Create the Data Lumos metadata record using the inventory and the metadata files as a guide. Upload and publish it to Data Lumos. Upload the inventory and mark it as being done. And then if there were questions or problems, post to the Mattermost channel and get some help. So that was like the labor that is set up. The division of labor, we actually have 2 groups. The first group were my students at Geodata at SciLi, which is the little lab that I manage here behind me at Brown. Last semester, I had 4 part-time undergraduates, and I committed them and me to uploading 5 data sets every week. And the inspiration for this is kind of like the open source software model, right? The companies will pay people to write, open source software because they benefit from that software's existence. The idea here is that we rely on these data sets. We're going to build these community contributions into our work. And it ensures that we're going to be constantly making steady progress because we're always going to have, 5 people who are going to be doing 5 data sets every week. The students also helped me out with testing the documentation and making sure that the process was smooth so we could perfect the workflow. Once we were happy with that, then the Data Rescue Project put out a call for volunteers. They joined the Mattermost channel. I posted the documentation at the top of the channel. We hosted some office hours on Zoom so we could talk about the project and I could demonstrate the process. And ultimately, we had about 15 volunteers who joined up. So 15 volunteers and then 5 folks from my lab. So 20 people participating. The work really got rolling in September and October. And we really did have an enthusiastic group of people who are constantly contributing and innovating the process. So one of the bottlenecks that we encountered was, uploading things into Data Lumos could be kind of slow. So one of the volunteers, Chiara, wrote and published a Python script on GitHub using the Selenium module in Python that allowed you to basically run the module in the Firefox browser, and you could autofill a lot of the metadata fields in Data Lumos for some of the boilerplate metadata that we had. And then another volunteer, Seth K, he enthusiastically adopted it, promoted it to other people on the channel. And once they did that, it really helped kind of boost and turbocharge the upload process, which was great. And then down here, these quotes are just some examples of the chatter on the Mattermost channel. People were really concerned about making sure that they get it right. So people were saying, hey, I finished these rescues. Would you guys mind taking a look, make sure I did it right? What do we do about these date fields? What is the correct process? So having that channel was really helpful for keeping us all together and on track. While the volunteers are doing the uploads, we're still doing stuff here in the background. We still had files that were missing, and my students worked to kind of track those down. There were some series level records in the portal, so like a record for the collection, and then records for all of the items. But the collection record didn't have any data associated with it, so we had to carefully identify and remove those. We had some rather large sets that I knew were missing, like the FEMA flood hazard layers. though that data was stored in like 50 plus individual geodatabases, one for every state and territory. So one of my students wrote some programs that would loop through those databases and produce the output that we needed that would match the original HIFLD data. And then some agencies like the US Army Corps of Engineers, they had a web mapping service. And if you connected to their web mapping service, you could basically see all of their layers in QGIS. And for ones that were missing for whatever reason, we were then able to export those and save them and get them into the process. And then as the volunteers were adding stuff into the spreadsheet, one of my students was doing quality control and kind of standardizing things that people were typing and entering in. So we have this foreground work going on, also work going on in the background. And by mid-December 25, we basically hit the finish line. So all of the records were claimed by the end of November, by Thanksgiving. One of the volunteers noticed this, went in and created a chart that showed us the status of everything that was left. And we used that to put out a final call for people that had claimed data sets but didn't actually get around to doing them. So I set a deadline. Half the people went in and basically finished the claimed stuff. For things that were not claimed, my students hopped in and basically finished those up. Got a blog post posted to the Data Rescue Project website. And also the final inventory sheet, we also uploaded as an index file. So that's available in the repository as well. So just in time for Christmas, we finished rescuing the HIFLD data and preserving it in Data Lumos. So what did we learn? Some things that I learned for project management wise. The Mattermost was really essential for communication. So the fact that if we had to do all of this stuff through email, it really would have been a nightmare. So having that communication platform was really essential. Again, I'm a stickler for documentation. Not only does it help get folks started, but it also helps keep us focused, right? So 2 months in, a question comes up. What do we do? Well, let's go back to the documentation and remember what it was we said we were going to do. Even with documentation, you still need to have some hands-on support, the Mattermost channel or the occasional Zoom call to figure things out. I mentioned the division of labor was really helpful for making steady progress. The crowdsourcing was great in that it allowed for steady progress and innovation. So I can imagine if we had a more, button down, top down, structured, strict process, that might cancel out or prevent some of the innovation that happened, right? With people writing their own script to improve the process and other folks adopting it. So the crowdsourcing was very helpful to allow giving people flexibility to innovate. The downside is it does make standardization a little bit more challenging. So I know that our metadata is probably not as perfect or tidy as it could be, but that's just one of the trade-offs. Using a cloud-based spreadsheet for keeping track of everything is nice. It's easy to deploy, but it doesn't scale well. We were able to do it for this project for 400 data sets, maybe 20 columns. I would get concerned going higher than that because you can imagine looking at people trying to keep track of a spreadsheet with thousands of records in it and everybody sharing it. It could be prone to error, but I think we were just under the limit of what we could do with that. And we were very fortunate that we had a storage mechanism for transferring the data with Globus. One thing I'll just mention, why didn't you just create another ArcGIS hub site? Because that's ideal for being a GIS repository, and the original platform was a hub site. Why not just do that again? Well, I would say that for this, time was of the essence. The portal was gone, and people needed access to that data and were reaching out to us and asking us for help. The data that we had was contemporary now, but it wasn't going to be contemporary forever. And while, here at Brown, I have access to, we have an Esri license and I have access to all that stuff, I have no support whatsoever for quickly standing up a website and certainly not maintaining it. And at the time, there wasn't really that kind of a support in the group either. Meanwhile, the Data Rescue Project already had all of these systems and workflows that we could deploy immediately. And in thinking about preservation, we want to, this is the long game. The ICPSR folks, they're like the repository people. They've been around since the early 1960s. Data Lumos as a website now has basically really reached critical mass. I think there are 2,800 data sets in there now. These are things that are likely going to outlast any one person's effort or a few people's effort to put up like a one-time, one-shot website for something. And I thought, if our goal here is just to preserve the data, other groups that maybe have the times and the means could come along and maybe build, something that has more bells and whistles. And guess what? That is exactly what happened. Let's talk about, just to wrap up here, future steps and next possible directions. HIFLD Next. This was a portal created by the Public Environmental Data Partners and Fulton Ring. They were able to take the data that we preserved and they built a fuller-fledged like a GIS repository that has more bells and whistles, these kind of categories for filtering. You can preview the data tables and preview the geography. Beyond just being a website, though, these folks are hoping to build a community of practice around this so that we're not just, okay, we plunked this one data set in here, but let's think about how we can maintain this. There's a value in keeping like an updated portal. So how can we work together to update all of the data sets and provide it through here? So I would strongly recommend folks go here and check it out. They also have a survey where they're eliciting feedback. Definitely get them some feedback and think about getting involved in this if this is something that interests you. Fed Geo Day is happening next week. This is basically an annual conference of open source and open data people in the federal government and contractors. One of the sets of conversations that's going to be happening there are conversations with the data creators of all of these data sets and the people that built HIFLD Open, and how we can form connections between nonprofit, higher education, and federal government folks for preserving federal government data. Those are kind of tangible things. Kind of fuzzier, maybe big picture things in terms of the future. I think libraries and research centers, I think we need to do something to integrate volunteering into our work. Because in higher ed, we really rely on federal government data. And I think we need to do more to help sustain that ecosystem. Instead of just having a bunch of volunteers in their spare time cobbling things together, this is something that we have to build into our work. And that could mean as part of our workflow, we're contributing to the Data Rescue Project. We're contributing to the OpenStreetMap, or we're creating our own value-added data. This image on the right here is of the Ocean State Spatial Database. This is a little geodatabase that we create here in my lab to give people an opportunity to easily get started with Rhode Island-based projects. And as part of that project, we actually create certain layers for the state of Rhode Island that they are not producing. So I know this may be a tough ask. You're like, Frank, are you crazy? Do you know, if you're a data librarian, do you know what my job is like and all the things that I have to do? I totally understand that. I totally agree. Two things I would say. First is it is always good to take time and kind of reassess all of the work that we are doing. Being an academic librarian for 20 years, as I look at all the things that I'm asked to do or expected to do, there are a number of those things that I spend time on that I don't think I should spend as much time on. If I had to rank all of those things and include these projects in the list, I think these would move higher up in the list. So I would advocate for taking some time and kind of reassessing where this could fall in the priorities and maybe letting go of some things that maybe aren't worth as much time anymore. The second thing is if it's a matter of getting justification, this work, at least in my experience at Brown, has had overwhelming support from the faculty. They are very happy and very pleased that we are participating in doing this work and strongly support it. For those of you who are working at data centers, I think academic research centers are going to play an increasingly important role as the government has kind of receded from some of its like data aggregation and storage work, that this is something that data centers can kind of step in there and hopefully fulfill this to some degree. These centers are all examples of centers that put data at the center of their center. So they archive, preserve, aggregate, or build data sets as a focal point, and then research activity basically springs forth or circles around the different data sets that the center provides, which I think is a really excellent model. And moving towards the conclusion here, I know that we are in a particular political and social moment in our history where our data structure or data infrastructure is imperiled. But eventually, when this moment passes, it doesn't necessarily mean that we are out of the woods. This is still a fragile ecosystem. So my more recent thinking about this actually predates 2025. Back in 2024, at the beginning of that year, I was helping some researchers find this county climate data set that basically at the county level provides you a summary of temperature and precipitation for every county going back 100 or 120 years. And this was produced by the National Centers for Environmental Information at NOAA. And the professors were like, this is great. This is something we'll use this. Months go by, and then they come back to me and say, hey, Frank, we have a question about the methodology that was used to create this data set. And then I went back to try and look it up, and there was no website. It was down. And then a few days later, it was back again with a yellow bar that said that the servers were unavailable. Well, what was going on? This thing here, this hurricane was this Helene, was happening in 2024. And the NCEI is headquartered in Asheville, North Carolina, which was really devastated by this hurricane. So I think in Silicon Valley, there's a lot of fiction that is spread. One of the fictions is like the fiction of the cloud, that everything is just floating up there in the cloud and it's all going to be all right. There's no cloud. There are machines that are plugged into a wall and they require a lot of electricity and water. And if that machine goes down, the data that's there goes with it. And using all of my librarian tricks, this was not in the Internet Archive. They hadn't captured a picture of this. So just beyond this political moment that we're in our history, I think we really do need to think, we can't take it for granted that stuff is just going to be safely stored out there, but we have to think about, building some redundancy for the sake of preserving the data. All you really wanted to know is, where is all this data that you saved, Frank? This is the slide for you. You can go to Data Lumos and just do a search for HIFLD Open, and then you'll get a list of the individual layers which you can download. Alternatively, there are instructions here that if you've got a Globus account and you want everything, you can go to Globus and basically transfer the data from our repository there. And of course, don't forget about HIFLD Next and give that a try, because that's beyond being an archive. That's something that hopefully is going to be updated in the future and is going to grow. Many thank yous. Thanks to all the Data Rescue Project HIFLD volunteers, my students at Geodata at SciLi, all the Data Rescue Project organizers, especially Linda and Lena, the staff at ICPSR for all their support with Data Lumos, PEDP and Fulton Ring for creating HIFLD Next, all of the folks in the federal government who produce all of our statistics and GIS data, the Big Ten GIS Conference organizers for inviting me today, and thanks to all of you for coming and attending this presentation. And now I'll catch my breath and see if there are any questions.
Unfortunately, you won't be catching your breath for very long because there are a number of questions, which I'll get to one by one. This first one, I think, was one that you've already answered with one of the slides, but the question from an anonymous attendee was a workflow created for updating the HIFLD data to bring it current using the data from those 30 or so original sources?
In this case, no. The focus was just on preserving what was there. But as part of the next steps with the public environmental data partners and at the GeoDay, we're going to discuss what can we do to keep these data sets updated. In some cases, it may just be going to a website and downloading a geodatabase that's updated once a year, or tapping into a web mapping service and just on a recurring basis downloading stuff from there. Or some of these data sets were bespoke, like they were created as a one-time thing, and somebody will have to figure out, how do we do that again?
Thank you. Next question was, why did the government get rid of this incredibly rich data set?
The explanation was very terse in that it said, this no longer fits within our current mission and priorities, period. Beyond that, from an official stance, I don't know why it was discontinued.
That's a good answer. The next question is thanking you for your work, but saying, if we someday have a government that cares to support these data sets again, do you think it's feasible to get data sets back where they belong? And I assume that effort would be Herculean.
Yes, it would be hard, because it's not just a matter of the data being removed, but also the infrastructure for like collecting it and updating it and keeping it up to date. So if the people that conducted like a survey are no longer there and we have a break in the time series, then that would be harder. But I think, it is important to remember, though, and I'll see a lot of these folks at this conference, that there are still tens of thousands of federal employees who work with statistics and data and GIS who are continuing to come to work every day, and they're following their norms and standards and best practices. We just have to do what we can to support them in the interim until, the situation improves.
All right, thank you. Frank, there's another question that says, beyond metadata, are there protections in place to validate the provenance or chain of custody of these salvage data?
I can't give you a specific example off the top of my head, but I know there have been specific projects where people are doing, they're looking at files and they're running a checksum against the file to determine, like, has this file been changed or modified since it was last published? So there are folks who are doing that. But off the top of my head, I can't remember what the name of that group or initiative was. But if you go to the Data Rescue Project's website and you can dig around the blog posts there, and there's also a directory of other projects, you can find links to that information and to those resources for doing that. I know there has been attention on, there's not just a matter of the data sets being removed. Some data sets have been taken down and modified to remove certain things and then put back. And I know there are a lot of people that are paying close attention to that.
Okay, thank you. This next question comes from one of our own. Thank you for being a part of this work and your excellent presentation. I love that undergraduates were a part of your workflow. Could you say some more about how to integrate student library employees or research assistants into this kind of work? And if that kind of collaboration is common across volunteers or if it's unique to you?
Well, I'll say that in the work that I've done here at Brown and also at CUNY, I've always had a small lab, and my only employees are students that I can hire. So those students are always, I hire them to kind of support the ongoing consultation work that we do. And also we have a map collection here that we also maintain. But beyond that, it's also a mentorship opportunity and an opportunity to learn. And we do have our own projects that we do, but now beyond just doing our own thing, there are all of these volunteer efforts that exists like this one, that in thinking about our projects for a semester, I'm thinking more about those volunteer projects instead of just doing something new and beyond updating our own things, just making it part of the workflow. Like, okay, for this semester, these are the things that we're working on, and we're going to participate in the data rescue project, and we're going to make sure that we do X number of data sets a week or something like that. There may be opportunities too, and beyond in the library and different classes. So I know a number of the professors who were using data that disappeared were very interested in integrating data rescue work into their class because of that.
That's great. One more question, and then I swear you'll get to take a breath again.
It's okay.
Has a wiki of the information that could act as a catalog of sites and themes around the information been discussed? There's a wiki builder that uses README files to create wiki pages that might be user-friendly for updating a catalog of metadata for information.
Huh. Within the data rescue project, yes, there are some folks who are working on creating a wiki that was specific to basically capturing the work that we did. So, for example, everything that I just described here in this presentation, what workflow did we use so that we could remember that? And then so other people maybe could replicate it for other projects. So I think that that's something that somebody in the project is working on. Specific to metadata, I'm not sure. In this case, metadata was fairly good because we were working with GIS layers. Most of the agencies had to produce, FGDC compliant metadata, and we had good records. For a lot of the other data sets for kind of like the general rescue, the mileage really varied. There may not have been anything other than a brief description on the website. So yeah, it's an interesting suggestion. I'd like to hear more about it. But yeah, that's my take on it off the top of my head.
hopefully we can keep talking about it in the future. But Frank, thank you so much from all of us. We are so glad to have you, and I know there's 190 people clapping right now at least. So thanks
Great.
for your time.
My pleasure. Hope to see some of you in person someday too. So thank you very much.
Absolutely.